dear students, in differential calculus, so many number of topics are there. So from the beginning till now, you what and all you have learnt? Yes, you know, first part it's limits, and second part is continuity, and third part differentiability, and then application of differentiability. So that means so many aspects are there. So far you have learnt only about limits in previous classes, and other things what and all you have learned only about limits. Now we are very compact with the concept of continuous. What is continuous? You have learnt in other classes, even lower section also you have learnt in continuous. In continuous means what? See, anything which is so continuity. So are you studying right from LKG to 12th standard continuously? That means what? There is no break, that is all. They are asking that. That means the question is very simple. Is there any discontinuity? Is there any discontinuity means during the interval of 12 years or 14 years of your learning, any discontinuity is there. So likewise, here also the continuous they are defining in other way. That is, we are taking as a function here. What is a function? So anything which we are going to comprising with our own limitation, that is what a function here. So that means we should have a domain and we should have a codomain. Both the things are considered to be, so domain is a must. For anything function to be defined, we need to have a domain. Okay. Now what is closed interval? And certain terminology you should understand. The closed interval, open interval. What is closed interval? Closed interval is the interval in which the values are lies between or equal to those values, and open interval the values lies between both ends, that is all. If at all, if I say 1 and 2, so 1 lesser than or equal to x, lesser than or equal to 2 means 1, that is closed interval. 1 strictly less than x, less than 2, it is open interval. And neighborhood point. Neighborhood point is nothing but x naught. So that x naught, that is the point neighborhood, which I would like to say in future are some problems how this is going to be applied. Now let us see this continuous. Let me define about the continuous now, definition of continuous. So before going to this problem, I wish to define about continuous. What is continuous? A function f is mapping from a closed interval a comma b to a real number r is continuous on closed interval a comma b, and if it is open and if it is continuous on open interval a comma b, then I wish to define about it limit x tends to a plus f of x, that is f of a, remember that, and limit x tends to b minus f of x equal to f of b. See, this is what a continuous case. So continuous I wish to define like this. So if you know this concept only, you can think about continuous. Is it okay? But in what way we can say about the continuous? The continuous from the left at a, that means from left at a, that is what the x tends to a upon plus, and x tends to b upon minus, that is what the continuous for the right side. So that means the limiting value, that means then f is continuous from the left at A and f is continuous from the right at A. Here left at A and right at B here. This B, right? That means this is the one towards this and here towards A. This is A plus, remember that. This is B minus. So, between this limiting point, I am just saying the entire thing is continuous and it is continuous at x naught. That is a neighborhood point which is in the open interval. So, anywhere else here that x naught, that is between A and B. So, this is what the definition of continuous. So, remember that. Now, let us think about this problem. Why I have taken this definition for your point of that, you should know what is continuous and how we are going to take this problem for your reference point of it. So, that is the reason why just we have taken. Now, this problem is what? At the given point x naught, this is what? Discover whether the given function is continuous or discontinuous. So, continuous and discontinuous means at what point it is continuous. So, it is everywhere that point is there. See, from the A up to B, right of left of A, left of, see here, continuous from here, I am sorry. So, one more thing, that is it is right at A here, left at B, left at B, right at A. So, that means here right at A means towards this direction, remember that, right at A, left at B. That means here the function is for x we are taking here, continuous at x is equal to 1. This is the point they are asking. This point is very important point, remember that. X naught is equal to this. Function is what now? F of x is equal to x square minus 1 by x minus 1. This is what the function. And the function have two values. Now, if it is not equal to 1 only, this function exists. If it is equal to 1, 2 is the function exists. So, that means according to the question what they asked here, at x is equal to 1, that means f of 1, when I substitute this value carry over 2, that is the first result. Let it be here. Let it be taken here, at x is equal to 1, f of 1 is equal to 2. Okay, we got. So, here the question is, x is not equal to 1, there is a function defined for which only we have to take into consideration for the problem side. We have to check whether it is continuous even though at that point of x is equal to 1. If we are getting the same codomain or a range, that value if I get, that means it is continuous. If I am not getting the codomain or range, definitely this is not continuous, discontinuous. That means. So, now let us think over. Take the function, let f of x, or given that f of x is equal to x square minus 1 by x minus 1, when x is what is it? Not equal to 1. Now, the function is taken here. So, this is the one. Now, limiting point we have to consider. So, here you simplify this term, that is nothing but x minus 1 and then x plus 1 by x minus 1. Here this is the function here. So, this one I have factorized a square minus b square. This I have taken x square minus 1 square by x minus 1. A square minus b square, a minus b into a plus b by way of deleting. So, I am getting x plus 1. So, f of x. So, according to the sum, according to this definition, it is right at A, left at B. Right at A means what is that? I wish to know towards x is equal to 1. That means limit x tends to 1 upon, that is plus f of x. So, that means in the place of x we are going to substitute 1 over here, that is 1, that is 1 plus 1, I am getting 2 here. Even though it is the right limit of 1 upon, that means this value, see here at x is equal to 1 it is 2, and we are checking whether it is for other value 2 for the function, we got 2. So, from 1 and 2 what do you understand? 1 and 2 we infer that f is continuous at x is equal to 1. This is a point. This point is a very important point at x is equal to 1. See, given that x is equal to 1 is 2, that is a codomain, that value f of 1, this is domain, so 2, and f of x, the function, we have taken the value substituting over here and we found out 2. So, that means by way of comparing 1 and 2 we have the same result, therefore, f is continuous. If at all, sometimes if I am getting some other value other than 2, definitely this is discontinuous, but for this problem it is a continuous.